There is a known compatibility issue when using touch-sensitive dimmer switches with arc fault circuit interrupted breakers, commonly referred to as AFCIs. AFCI breakers are specifically designed to detect and trip in the presence of arc faults, which can arise from various sources like loose connections or damaged wiring. The operational characteristics of touch-sensitive dimmer switches can sometimes mimic or generate electrical signatures that AFCI breakers misinterpret as actual arc faults. This misinterpretation leads to the breaker tripping even when a genuine hazardous condition does not exist. Therefore, it is generally not advisable to pair touch-sensitive dimmer switches with AFCI breakers on the same circuit. If encountered, try alternative dimmer switch types, such as those using a different dimming technology. When troubleshooting issues with dimmer switches and AFCI breakers, there are several key aspects to consider. Firstly, ensure that the dimmer switch is fully compatible with the specific type of light bulbs being used. Some dimmer switches are designed for incandescent bulbs, while others are compatible with light-emitting diode, commonly referred to as LED, or compact fluorescent lamps, known as CFL. Using an incompatible dimmer switch can lead to flickering, reduced bulb life, or even damage to the dimmer switch itself. Secondly, verify that the dimmer switch is wired correctly according to the manufacturer's instructions and relevant electrical codes. Incorrect wiring can cause a range of problems, including dimmer switch malfunction, circuit breaker trips, or even electrical hazards. Thirdly, check the breaker panel to see if the AFCI breaker has tripped. A trip breaker indicates that the circuit has experienced an overcurrent or arc fault condition. If the breaker has tripped, reset it and attempt to use the dimmer switch again. If the breaker trips repeatedly, this suggests an underlying problem that needs to be addressed. If you have thoroughly checked these aspects and are still experiencing difficulties getting the dimmer switch to work, it is recommended to seek assistance from a qualified electrician. Electricians possess the expertise and tools necessary to diagnose and resolve electrical issues safely and effectively. Additional troubleshooting steps may involve testing the circuit voltage, checking for loose connections, or inspecting the wiring for any signs of damage. Remember that working with electricity can be dangerous, and it is always best to err on the side of caution and consult a professional when in doubt. The National Electrical Code, referred to as NEC, provides guidelines and regulations for electrical installations to ensure safety. Although the specific edition referenced is the 2008 NEC, the underlying principles regarding AFCI protection and dimmer switch compatibility remain relevant across different code cycles. AFCI breakers are designed to protect against arc faults, which are unintentional electrical discharges that can ignite flammable materials and cause fires. The 2008 NEC and subsequent editions have expanded the requirements for AFCI protection in residential circuits to enhance safety. When selecting a dimmer switch, it is important to consider the type of lighting load it will be controlling. Incandescent bulbs are relatively simple to dim, while LED and CFL require dimmer switches that are specifically designed for these types of bulbs. Using a dimmer switch that is not compatible with the lighting load can result in poor dimming performance, flickering, or premature bulb failure. There are two main types of dimmer switches: phase-controlled dimmers and pulse-width modulation, known as PWM dimmers. Phase-controlled dimmers work by chopping off a portion of the alternating current, known as AC, waveform, which reduces the amount of power delivered to the light bulb. PWM dimmers, on the other hand, rapidly switch the power on and off, varying the duty cycle to control the brightness of the light bulb. PWM dimmers are generally more efficient and provide better dimming performance than phase-controlled dimmers, but they are also more expensive. When installing a dimmer switch, it is important to follow the manufacturer's instructions carefully and to ensure that the wiring connections are secure. Loose or faulty wiring connections can cause arcing, which can damage the dimmer switch or create a fire hazard. It is also important to use the correct size wire for the circuit and to ensure that the dimmer switch is properly grounded. If you are unsure about any aspect of dimmer switch installation, it is best to consult a qualified electrician. Electricians have the training and experience necessary to install dimmer switches safely and correctly. They can also help you choose the right dimmer switch for your needs and ensure that it is compatible with your existing electrical system. When troubleshooting dimmer switch problems, it is important to start by checking the basics. Make sure that the dimmer switch is properly connected to the circuit and that the wiring connections are secure. Also, check the circuit breaker to see if it has tripped. If the breaker has tripped, reset it and try again. If the dimmer switch still does not work, you may need to replace it. Dimmer switches can fail over time due to wear and tear or electrical surges. When replacing a dimmer switch, be sure to choose a dimmer switch that is compatible with the type of light bulbs that you are using and that is rated for the wattage of the lighting load. It is also a good idea to choose a dimmer switch that is energy efficient, as this can save you money on your electricity bill over time. In addition to the above troubleshooting steps, it is also important to consider the age and condition of your wiring. If your wiring is old or damaged, it may not be able to handle the load of a dimmer switch, especially if you are using high wattage light bulbs. In this case, you may need to have your wiring upgraded by a qualified electrician. Upgrading your wiring can be a costly undertaking, but it is an important investment in the safety and reliability of your electrical system. It is also important to be aware of the potential fire hazards associated with dimmer switches. Dimmer switches can generate heat, especially when they are used to control high wattage light bulbs. If a dimmer switch is not properly installed or if it is overloaded, it can overheat and cause a fire. To prevent this, it is important to follow the manufacturer's instructions carefully when installing a dimmer switch and to ensure that the dimmer switch is rated for the wattage of the lighting load. It is also a good idea to inspect your dimmer switches regularly for any signs of damage or overheating. If you notice any problems, have the dimmer switch replaced by a qualified electrician. Another factor to consider is the type of dimmer switch that you are using. Some dimmer switches are designed for use with specific types of light bulbs, such as incandescent LED or CFL bulbs. Using the wrong type of dimmer switch can cause problems with the light bulbs, such as flickering, buzzing, or premature failure. To avoid these problems, be sure to choose a dimmer switch that is compatible with the type of light bulbs that you are using. In addition to the above considerations, it is also important to be aware of the local electrical codes. Electrical codes vary from jurisdiction to jurisdiction, and it is important to comply with the codes in your area. Electrical codes are designed to ensure the safety of electrical installations and to prevent fires and other electrical hazards. To ensure that your electrical system is safe and compliant with local codes, it is always best to consult a qualified electrician. Electricians have the training and experience necessary to install and maintain electrical systems in accordance with all applicable codes. Let's delve deeper into the technical aspects of AFCI breakers and dimmer switches, and how their interaction can lead to nuisance tripping. AFCI breakers are designed to detect specific arc fault signatures in electrical circuits. These signatures are typically characterized by erratic current waveforms, high-frequency noise, and rapid changes in voltage and current. The AFCI breaker's internal circuitry analyzes these signals and trips the breaker if it detects an arc fault condition. Dimmer switches, particularly phase-controlled dimmers, operate by chopping the AC waveform, as previously mentioned. This chopping action introduces harmonic distortion into the current waveform. Harmonic distortion refers to the presence of frequencies in the current waveform that are multiples of the fundamental frequency, which is typically 60 Hz in North America. These harmonics can interfere with the AFCI breaker's ability to accurately detect arc faults, leading to nuisance tripping. The level of harmonic distortion produced by a dimmer switch depends on several factors, including the type of dimmer switch, the type of light bulb being used, and the load on the circuit. Some dimmer switches are designed to minimize harmonic distortion, while others can generate significant amounts of it. Similarly, some light bulbs are more susceptible to harmonic distortion than others. For example, incandescent bulbs are generally less affected by harmonic distortion than LED or CFL. The load on the circuit also plays a role. When a dimmer switch is heavily loaded, it can generate more harmonic distortion than when it is lightly loaded. To mitigate nuisance tripping caused by dimmer switches and AFCI breakers, several strategies can be employed. Firstly, using a dimmer switch that is specifically designed to minimize harmonic distortion can help. These dimmer switches typically incorporate filters or other circuitry to reduce the amount of harmonic distortion they generate. Secondly, using light bulbs that are less susceptible to harmonic distortion can also help. Incandescent bulbs are a good option, but they are less energy efficient than LED or CFL. If you prefer to use LED or CFL, choose bulbs that are designed to work with dimmer switches and that have a low total harmonic distortion rating. Thirdly, reducing the load and the dimmer switch can also help. If you are using a dimmer switch to control a large number of light bulbs, consider splitting the load across multiple dimmer switches or using a dimmer switch with a higher wattage rating. Fourthly, consider using a different type of dimmer switch, such as a pulse width modulation, known as PWM dimmer. PWM dimmers do not chop the AC waveform and therefore do not generate as much harmonic distortion as phase control dimmers. PWM dimmers are typically more expensive than phase control dimmers, but they can be a good option if you are experiencing nuisance tripping problems. Fifthly, ensure that all wiring connections are secure and properly made. Loose or corroded connections can create arc faults that can trip the AFCI breaker. Check all wiring connections in the circuit, including those at the dimmer switch, the light fixtures, and the circuit breaker panel. Sixthly, if all else fails, consider replacing the AFCI breaker with a standard circuit breaker. However, this should only be done as a last resort, as AFCI breakers provide important protection against arc faults. If you do replace the AFCI breaker with a standard circuit breaker, be sure to install arc fault protection elsewhere in the circuit, such as at the lighting fixtures. Furthermore, the type of can lights being used could contribute to the issue. Older can lights might have insulation that is degrading, potentially leading to small arc faults, especially when used with dimmers. Upgrading to newer, insulated can lights specifically designed for use with dimmers could resolve the problem. Pay close attention to the dimmer switch's specifications, ensuring it matches the voltage and wattage requirements of the can lights. Also, verify that the dimmer switch is designed to handle the specific type of bulb within the can lights, whether they are incandescent, LED, or CFL. The 100 watt rating per can light is relatively high. Ensure the dimmer switch is rated to handle at least 400 watts plus a safety margin, maybe even 500 watts total. If the dimmer is underrated, it will overheat and likely cause problems, including premature failure and potential fire hazards. The lack of nuisance tripping might suggest the dimmer is simply not functioning correctly with the lights, or that the AFCI is not sensitive enough. However, the primary concern should be safety and proper operation. If the lights are not turning on at all, even though the dimmer appears to be powered, this also suggests a compatibility or wiring issue. Double-check the wiring diagram for the dimmer and confirm it is wired correctly to the can lights. It's possible there is a neutral or ground fault causing the problem. A ground fault occurs when current flows through an unintended path to ground, while a neutral fault occurs when the neutral wire is not properly connected or grounded. Both can cause electrical malfunctions and safety hazards. A multimeter can be used to test for ground and neutral faults. Consult an electrician for assistance if you are not comfortable performing these tests yourself. If the dimmer switch is a smart dimmer, ensure it is correctly configured and communicating with the can lights. Some smart dimmers require specific settings or firmware updates to function properly with certain types of bulbs or lighting systems. Refer to the manufacturer's instructions for details on how to configure the smart dimmer. In summary, a systematic approach is crucial when troubleshooting dimmer switch and AFCI breaker issues. Begin with the basics, such as checking wiring connections and ensuring compatibility between the dimmer switch, light bulbs, and AFCI breaker. If problems persist, consider more advanced troubleshooting techniques, such as testing for ground and neutral faults. When in doubt, consult a qualified electrician for assistance. They possess the expertise and tools necessary to diagnose and resolve electrical issues safely and effectively. Remember to always prioritize safety when working with electricity and to follow all applicable electrical codes.